Hello. In this video, I'm going to continue with Loki programming language. I'm trying to make everything better. Okay, I think it's good now. So, as you know, we were working on a new programming language that is going to be both transpiled into other programming language and also be it has its own basically native code gen mechanism. So we were working on the parser. Parser is now finished. There are these things left, which are simple things. And since we used this parser combinator pattern, which was amazing, I mean, it just made everything so simple. I mean, if you take a look at each part of each part of the parser, I mean, for example, take a look at the expression. Expression is nothing but either a float, either a uint, either an int, either a boolean, string, if, function definition in a struct, function call, identifier, or an array, any of them is just an expression. Or a declaration is nothing but some white space identifier, basically this is the how we do declaration. Identifier, optional type inference equals expression. So this is it. Now all our tests are passing if we run them. And also you see that we have some not so simple tests, like for example this one. This is basically defining a function. It's not defining, we don't have functions, are just values in this language, at least the way we look at them at the parsing level and at the syntax level. So each function is just a value, so we need to assign it. These are just expressions, but we can also assign them. So I wrote this test called parse module. Basically a module of Loki is going to look like something like this. So with that in hand, let's move on. So now this test passed, so we can parse this. And it will give me main function. It basically gives me a list of declarations. So we already told you at the start, basically a program of Loki. I don't know where yes, I think I had this. Everything is just expressions, and so basically you just bind expressions to some names. That's a Loki program. So actually, let's write the first Loki file. Huh? I wanted to share this with you. So main.loki. What is main.loki? It's going to say main equals fn, returns nothing. Every statement. Oh, we don't have Loki yet. Hopefully we have someday. Let me try to do the font size with mouse. Mouse. Okay, it's here. Okay. Now it's better. Right. Okay. So fn main is print line or print. I'm gonna say print line. This means hello world in Farsi. Salam dunya means hello world in Farsi. So I want to parse this file using my parser, which we wrote. So how can I pass this to here? Let's see. I think we can, do something fun and use Rust clap. So clap is this Rust library for building command line applications. So we probably should use this for the compiler. So let's get the claps crates.io. If it help and open up, yes, it opens now. Okay, let's go into cargo.toml. We don't need this one, at least I know we don't need this. So cargo download. What was that? Cargo get fetch. What was the? Oh, come on, it's locked again. Good, really good. Let me connect my VPN and hope that this will pass now, because we have some problems with crates.io in Iran. So okay, again, this is the reason I don't do streams yet. I don't have a good and reliable network connection to work. Okay. let's see if this will pass or not. So we will give it time. So until it's running, let's see how we actually, so we can parse this program. We know that um, we can parse a program. But what's next? Let's talk about that. I don't think it's gonna work. I really don't think it's gonna work. Let me just do one thing. Now it should work. No, sorry, wrong button. Let's see if this works. Okay. Let's go into some terminal and do kill this VS Code cargo thing. I know you're here. So kill -9. Let's kill this. Let's kill this. And let's kill this. And let's kill 796. Let's close this as well. We shouldn't have anything left. 50042. Let's run code again. And hopefully this will work now. I don't know. So we are going to talk about how we are going to write the code gen backends for this compiler. So I don't know why these not work. Okay, you know what? Let me pause the recording and fix this. Come back to you. So it's fixed now. Okay. So basically, what we are going to do, as you see, for example, in the module test, this is basically what we are going to do. We are going to pass a module into the CodeGen tool or CodeGen backend, and it would give us a basically. So how this is going to work? So let's take a look at README, and at the same time, let's take a look at the README of the project itself. So where's the OBS? Oh, okay. Okay, cool. So the Loki, if we go inside, so we can assume that we are finished with this parser. I know there are parts left, but they're easy. I'm gonna do them. Then we are going to have this part. We can skip this part. So this is basically one of the things. So we can skip this part for the type inference, and we can assume, at least in the C backend, that a user would provide types always. Okay. And we are also going to skip comp times for now. I'm just gonna build something that can run something, and then probably we are going to start with the semantic analyzer, and probably we are going to add the mute keyword after that. But I'm just gonna work on the target code gen tonight. I'm just gonna make this work. I really want to, see it in action and see something. I mean, it's been a long time I'm working on this project. I really want to see some results now. So what I'm going to do is, so I have the clap. Let's see. There was this builder API, which I like more than the other one. So would you please give me some example? Oh, actually, you know what? I can cheat. I have this small program written in Rust as just, some exercise. Let me find this. it's this is it, Gist, which is a simple program to manage gists, and we have this functionality in here. Cool. So imagine we have that. Let's do use clap arg matches. Okay. Also command also arg. Cool. So the command name is going to be Loki, of course. This is me, this is me. This is going to be Loki compiler. For now there is no arg, or is it? I don't have args, so I have this run. Actually, let's have that arg back. So it's going to be a new argument called backend, or backend, which is not required. The short version is B, long version is backend, takes values yes, backend to use for code gen. Okay. And also, so in here, I have this command called, I have this command called compile. It has a new argument. Which is, can it be positional argument? Something like that? Some kind of positional argument, or not flag actually, so something like this. Okay, where's this example? Where's the source code? Command arg this. Oh, it's using this command.arg this. Okay, let me just copy this. Bring me VS Code. Okay. And remove this. Yes, I need to import it. What's wrong? Okay, seems fine. Seems fine. So also there's no argument on this. So subcommand is going to be a command. Oh my god. So this is going to be close this subcommand. What's wrong in here? Okay, cool. So you know what? Let's just run this and see how this goes. So for running this, I should probably call this parse CLI. Give me some matches. And on matches, I can say get. I can say dot yes. So I'm gonna say args get value of a specific option or position. Argument that takes that. So can I say can I say backend dot unwrap or expect needs a backend. I don't want to test it as we probably have a default backend of some sort. So it's going to be my backend, and I'm gonna print this. Generating code using this backend. Okay. Let's run. Finally, cargo run, and we need a backend. Okay, so backend is going to be -b, for example, C. Generating code using C. Cool. So we can also have, for example, JS. Go. Nice. Okay. Cool. So next step is going to get the file name. So file name is going to be matches matches dot subcommand what is this? Name of current subcommand. Okay. We can do no. I prefer this subcommand. Basically, we can match on this. And let's have a fn compile function for basically handling our compile command. You should have the same type of result. For now, we should probably bring anyhow into the game, hopefully, to make a better error handling system. So matches, no, sorry, I should just put this in here. So matches matches subcommand. It's going to be sum of a tuple, right? Yes, an optional of tuple. Sum of a tuple. I'm gonna say compile, and arg matches is going to compile the function. I'm gonna say arg matches. What's wrong with this function? What is wrong? Okay, so it's actually nothing. And pass arg matches into it. Okay, and anything is just unreachable. So, okay, it says that arg matches is a reference. So I'm gonna just make this reference. Okay, what else? Okay, it's just a return value. So now in here, I can get file name, arg matches, value of, should I say name, like this? Okay, it's an optional, expect file name needed. Okay, and then print line compiling this file name. Okay, and finally, can I or should I use anyhow result, and using this type of result is better. Also in here, maybe we should use this. Yes, it's better. Okay, so after these, everything should be okay. Okay, so compiling this. So what I should say, okay, let's run this. So -b, I'm gonna say C compile file name needed. So now let's pass the file name. Yes. So now it's working. Cool. So now let's just call our parser. As simple as that. So let's do format. Okay. So parser, bring me module. Module. We don't have module? I know we have. Public, make this public. So now this should be able to call module, pass the input. So how we should read something? Rust read file. I don't need Tokyo, I just need normal stdfs probably. Yes, just copy this. Okay, so expects fs read to string. Best function ever. So let's do stdfs read to string, pass the path, which is the file name, dot unwrap. Nice. So this would give me, let's say, call this an ASD. And now we should be able to print this. Write ASD. Okay. Run it again. Yes, it gives me the ASD. So in here. So it is basically a list of declarations. This file is list of declarations, right? That the first declaration is main. There is no type associated with it. We can this is where we actually, in the type inference, this is where we are going to investigate. When we see this, we are going to check the expression on the right side and find what is going to be our type. So for example, in here it's really obvious that our type is going to be a function that takes no input, so this is empty, returns void, so returns no output, and has some this that is not important in terms of the type for us. So now that we have that, let's actually start writing the backends. So what I'm going to do is call something called a C backend dot Rust. So what is this backend is going to do for us? Mod C backend. So the C backend, what it's going to do, it's going to generate C code based on this. So for now, let's just have this public function called CodeGen, which takes input, which is parser, parse object, and returns, let me import anyhow result type. So first of all, use super parser parse object. Also use anyhow result. So and returns a result of string, which is going to be basically the output generated code for us, right? Okay, cool. I don't need to specify this anymore. Actually, I want to rename this. I don't like this name. So let me name this, I'm gonna say ASD node. This should have changed also this, okay? Okay. So now it's better named. So how we should do this? So so for the C backend, what I'm what I was thinking was to use the Zig build system, so it would generate really fast and really optimized, and also really it would give us the caching system of the Zig, which is really fast and helps us, doing rapid development inside Loki as well. So what I want to have is going to have a function that says generate or bootstrap Zig build. Going to return a result of nothing. So basically what we are going to do, output there, which is going to be a reference to string. So in here what I'm going to do is stdfs. Is there kind of a write? Let's see how we can write files. So not Zig, Rust write file. So we can de facto standard of writing files in Rust. Okay, Rust and onwards. Read a file to string, read a file, write a file. Fs write this data. That's actually nice. So fs write, the file is going to be output there. That's the format. Slash build.zig. Write. This is the file. What content? I'm going to say constant zig build. Let's copy the basic Zig build file into here. So in here in build.zig we are going to have this. We are going to need to clear this up a bit. Can we do multi-line strings in Rust like this? Okay, no. Multi-line string Rust. How we should do this? For example, oh really? So I should do this. Okay, exe add executable is going to be called main, and it's going to be beside you called main.c. No exe. I'm gonna add these to you. Okay. Okay. I'm not gonna have any. Yes, I have the run step, but actually I don't think that we need the run step as well, but let's make this be here. Okay, cool. So cool. So we have the basic Zig build script. So let's write this into a file, into our output there. So Zig build is going to build our system. So let's write Zig build in this, and this returns a result, right? Let's just return it. Yes, IO result. What's the error? Yes. Next is okay, of nothing. So we should start with bootstrapping Zig build system. Passing the output there is Zig zig out like this, or C out. Let's just make this like this. So I should, if I just call this codegen, I should make it should make a directory for. I don't know if it makes a directory or not. Let's just try this. So it's also going to, for now, return nothing. Okay. So now let's call this C backend thing inside main. So after here, first of all, can I get this inside here? That's one question. No. Is there any way to access the parent or something? Can't I do this? No. So let's bring this back in here, and let's just say backend is a reference to string, and in here backend is going to be backend. So now in here, after the parser, what I'm going to do is, using C backend, I have the codegen function. Oh, sorry, it's not a method. So codegen gets a input, which is our AST node, and oh, it's actually not the AST itself, it's AST or node. Let's just make this AST. So it returns also the remainings, and this is the pattern we used in parser combinator, which we don't use. So then we have the C backend that uses the codegen. Codegen generates a Zig bootstrap for us. Let's run this and see what happens. So backend C compile main.loki. Did you create anything in here? C. I cannot see anything. Target debug. Oh, it does this in here. Loki examples, build examples, depths, incremental, and everything. Cargo build. Cargo build dash dash help. Can you give me the directory dash dash? Not all generated. Oh yes. Out there. Build dash dash out. Or let's just do cp target debug Loki in here. So if I run Loki, need a backend. Okay, so dash c dash bc, which is the backend. I want to compile main.loki file. Why it does not do anything? I cannot open this. So let's make the one-liner out of it. Cargo backend, what was the thing? Cargo backend and cp target debug Loki. Actually not cp, let's just run this. Run right? Okay, so and dash b c main compound main.look. Generating code using C compound main.look. Why it's not making the what if I make this dir? Make dir C out. Now run it. C out now that has the build.zig, which is nice. So let's just check if rust mkdir, how we can do an mkdir. Create dir in stdfs. Okay. So let's do that. Let's do it. Let me delete this one. Yes, and in the C backend, before this, do stdfs create dir Yes, now this works. Okay, cool. We get the build.zig file. Cool. And every time it's going to rewrite this, right? Okay, cool. So now that we have bootstrap zig complete, now we can actually do the code gen. So we have an input node, and each node is basically a set of this. And we can also assume that each node that comes to us as the C backend, at least for now, which are really early stages, we know that each node is going to be, so I can just do this. So let's just do it. So I can say match on the input. I'm gonna say root. Yes. So I'm gonna say if it's a okay, so if it's a what is a module going to be? Let me check that again. So a module is going to be a list. So if it's a parser ASD node list of decals, we do something. Otherwise, we do we can just do panic and say that cannot or C backend does not support this root. Okay, so in here each declaration, so I'm gonna create a function called handle decals. Handle decals is going to get nodes which are vec of AST node. For now, return a result of a string built. And again, I'm just going to handle this really simple. So I'm going to say for node in nodes, what I need, node dot match on the node. If it's an AST node, so each declaration, we're going to assume that these are all declarations. So if these are declarations, do something. Otherwise, do same error like this. So do this. Okay. So each declaration is going to be, for now, it's going to be box new of none. Not actually box new. Let's just do type. And so yes. Okay. Let me just do this for love of God. Okay, better. It's like this now. And so each declaration has a name, so name, right? Then we have this. And finally, it has also an expression, which is this, which is a box. So let's just do, it's not, cannot do this, right? We cannot do this. Type boxed, and let's make this e boxed. So now I'm gonna say that you know what? I'm gonna make this even simpler. If it's a decal, just handle decal. Let output string or output, let's say code, which is a vector of strings. No, it's vec new, vector of strings. Okay. So handle decal should be a function that takes a simple node, which is an AST node, of course. We know that it's a declaration, right? So you know what? Let's actually just unwrap it for now. So yes, so let's get the name, which is a string. We have a type, which is an expression, which is AST node. And we have also a value, which is also AST node. It's going to return a result of type string like this. So name, type, value. Pass these to this value. And also do this. And also do output code dot push this, not this. These are dot can I make these into? No. These are boxed values. How can I? I don't think I can unbox them. So let's just have this. So let's just say that these are boxed values like this. Okay. And it's a string. So it's box of an option. Okay, finally. So let's just say that if value, so I match the value and say if value is an AST node fn, if value is a fn args output or and block, I'm just gonna handle a function definition. That's it. So if value is this, and also like always I'm gonna panic on anything else, right? It's not node anymore, it's just value. So AST node, okay, args output block. If value is a okay, so we got the args. What I'm going to generate you know what, I'm gonna, can I do this? AST node ident. I'm gonna assume that this is an identifier. Oh, we can dereference it. That's something. Okay, no. And okay, so you know what? I'm gonna ignore even args, right? So output. And in here, I'm gonna do a cheat again. I just want to print this so badly. So I'm gonna include, I'm gonna pound include stdio.h. So this is one of the, so I'm gonna pound include this, and in here, so if I called printf, it should work on the code. So if I in here, I should just call, instead of this, just call printf. This should work. And in the C backend, if it's a function, I really need to think about this code generation. It's a lot harder to do right than it seems, but so let's just do return format. Let's just do the most naive implementation possible. It's a decal, so this it's a function declaration, so it's not this. So it's the output, the name, the args, and then real parents, and inside the block of code. So the first one is the output. And let's return type is, let's sum. I'm gonna say if sum, not sum, but return type of AST node dot ident oh my god, I'm so rusty. So if this AST node is return type equals output, so if it's I'm gonna say else is unreachable. I'm gonna say you cannot reach this. So just make this work. So I know that this is a box. Should I do output like this? If let. No. Okay, so if this. Okay. So if I get the return type, I have the return type as the string. What should I do about the block of code? Okay, no. I don't know what to do about the block of code. Block of code is hard because each one can be anything. I can do some other assumptions. I can assume in here. So I'm gonna say if let AST node. It's a list of statements block it's the most dirty piece of code I'm writing till the state. So if I have all the statements for a statement in statements, if statement, if let AST node fn call, if a statement is quotes is also going to be vector of a string like this. I'm gonna say if it's an fn call that has also unreachable, if it's an fn call with the name and args, to codes.push format actually I cannot ignore this, so I have this. It's going to be name and args. So let me check something. So yeah. So what should I do about the args? So you know, a good way of doing these is to have a trait for each. So having some kind of trait system to let each backend implement for itself on the AST node, something like the FMT display or something, and each backend implements that for itself. So then they can generate at least code for small stuff like these. a flat, it's a parser, not, it's an ASD node of stir has a string inside it. Else is unreachable as always. Okay, so finally let me just fix this. Return okay of I can do so yes. Okay, so this would be the argument. So name and the argument. This should fix this. This is just going to work for one parameter. Well, let's try that. Actually, you know what? Let's just return this. We're doing everything in the most shittiest way of possible. So let's just do it. So this should work. Okay. So what are you saying? That I'm not implicitly returning, but return okay of nothing, not nothing, to string. Okay, so now we have that. So cannot move. I can consider borrowing. Okay, so it's fixed now. So output code push handle decode this. Output code is okay, so it's going to be mute, and the output code is going to be separated by new lines. So I'm gonna do something like output code dot join. The separator is going to be \n. Do these need semicolon? Probably. Okay, so we join them. Okay, in here, after we get the list of decals, I'm gonna do handle decals. I'm gonna pass decals into it. It would give me an output. Alright. And finally, I'm gonna do the worst thing of all. So I'm gonna say output is this. So now I'm gonna say std finally. Hopefully we can write this. So the code gen is going to constant output there is reference to string c out what was the name output there. Same goes for this. Format there slash main.c format output there. The contents is going to be output. Okay, I write this and let's try this. So let's run this. We hit a crash, of course. So enter an unreachable code because where all all of these are unreachables. Oh my god. It's not even complete. It's problematic in this part because we have the list of statements. This is not correct. We have this, so we have this function. Okay, it seems much work to just fix something that is not basically working, and we should probably get rid of all this code I wrote. Maybe just this function is actually what we need throughout. So I'm just gonna call it, but we did good in this video. We actually initiated a C backend to generate our basically C code. What I think I'm probably going to have is I'm going to have a trait in here, say, so maybe what I need is to have this backend module, which is a general thing. It's going to have a trait called represent, for example, of something, and representation represent, just this, and this is going to be as implement the std display fmt like this. Should I say main include this as well? Mod backend. std_fmt display. So basically, if anyone implements this function, can implement a represent, and backends are going to do something like this. So impl represent for C, for example, or C backend. No, representation of T where. Can I do this? Can I do can I do something like this, where T is this? Yes, it seems that I can, which is nice. So I'm going to define a trait called T represent of T, which T implements the display method. So with this, I can say implement representation for AST node for C backend. For C, and then I can say have represent AST node for Go, and then I can have implementation of representation of AST node for anything else, JS or anything. That's one thing that we can do, and yes, that is basically it. And this represent is just should have fn show, returns a result of string, and this is anyhow result. So use anyhow result. I don't know if this is a good practice to represent. And self, should I do this? I don't know. Okay, so I think that's it for this video. So in the next video we are probably going to do implementation of this. Maybe I start on my own and see and play with this idea and see if this works for multiple backends and multiple languages. Also, there are refactors in here, and also these to-dos I'm gonna do. I'm not sure if I want to record them because they are so typical. This part is not. This part is fun. I'm gonna record this, but probably I'm gonna do refactors on the parser and actually try to extract these types into their own respective types. So then it's actually easier to work with them and reason about them and fill them actually in the code, because it's now really being unreadable. I mean, it's actually hard to understand. This is actually the arguments of the function. This is the return type, and this is the body. So that is pretty much it. If you like my content and want me to continue with these projects, please like this video and subscribe. And also, you can contact me on Twitter, Gmail, etc. That's it for this video, and until the next video, goodbye.